Hi everybody, it's Peter Hirschfeld here, a Unit Coordinator in ELA for Teaching Science EDU30064, and welcome to the Flick to Collaborate for Assignment 1 resource. This assignment has a word limit of 1800 words and it's weighted at 40% of your overall score for this unit, and it's due on Monday 27th of April 2020, 5 p.m, and that is week 7. So our assignment overview. In this assignment, you need to develop a teaching resource which consists of 2 parts. Part 1 requires you to develop 2 activities for a specific year level and content descriptor of your choosing from the Australian Science Curriculum or the equivalent state and territory curriculum documents. In Part 2, you analyse a range of assessment strategies that are appropriate for the activities you've developed. So, as potential classroom teachers, a very important aspect of this is developing and building your understanding and your skills related to designing and developing relevant and engaging lessons. So for this assignment, these lessons are science lessons, and within these 2 activities or lessons that you're developing, you need to include information communications technology, which I'll refer to as ICT throughout this, so I don't stumble over my words like I just did. And you also need to incorporate problem-based learning approaches to teaching within at least one of the 2 activities, if not both. You also need to display your developing skills to competently assess, provide feedback, and report on student learning. Assessment is an essential element of teaching, and this is our ability to select and implement good strategies that really, showing us what the children know, what they need to know, and how we're going to get there. And so these allow us to make accurate and meaningful judgments to inform student progress. So this assignment supports the unit learning outcomes of developing plans of lessons or units of work that reflect relevant curriculum documentation and contemporary pedagogical approaches, including the use of PBL and information communication technology, ICT. You also will be showing us how you analyse a range of assessment strategies and record-keeping instruments within science in terms of purpose, benefits, limitations, and implementation constraints. So, Part 1, 1300 to 1400 words approximately. We're actually going to be a little lenient on the word count for this. It says 1800, we're expecting your assignments will probably be around the 2000 mark. What we're interested in, good activities, well thought out, and good analysis of your assessment. So within this, we're aiming around 1300, 1400 words when we're thinking about it, and see how we go. So you will select one content descriptor from any of the F to 6 year levels of the national, state and or territory curriculum science documents. So one content descriptor, which means 1 year level. Both activities will be aimed at that, at developing the understandings related to that content descriptor, and it will be for 1 year level. Within this content descriptor, you need to outline the key concepts of the content area you've chosen. The key concepts need to align with learning objectives that you develop for the activities that you're creating. There's a link there, which you can see on the slides which are on the Padlet, to the Australian curriculum. I'll look at that later with you too. So, Part 1, that's 1300 to 1400 words. So, based on the learning objectives that you develop and the key concepts related to the content descriptor, you're going to develop 2 activities that relate to that. You're going to include associated teaching strategies within that activity that you'll use to teach the concepts. Now, please keep in mind that you're not developing a unit of work, but rather 2 activities that any teacher could implement within a unit of work for that content area. So they'd probably fit somewhere into a unit of work. They do not have to flow on from each other, but they would be somewhere developing those concepts clearly. ICT needs to be included in both activities at some level, and at least one of the 2 activities must use a collaborative problem-based learning approach. Week 3 readings cover that quite well. That's where you'll look for that. We'll talk about that in a minute. So for each activity, you need to also list the resources you'll use to help scaffold the children's learning of the key concepts, a little bit like with a recipe, your ingredients, what you need to do to run the lesson effectively. You also need to include consideration how each of these activities fit within the pedagogy you've chosen to deliver the activity. So for instance, how each of these fit into the PBL. And to do that, I'll explain a little more in a minute. So, you've been provided just with subheadings, no pro forma for this. You can set it out in a number of ways. We've had a look at a couple of student examples and they've chosen to display this in more than one way. So whatever suits you best, but you must include these headings. Year level and content area, which would make up approximately 10 words. Key concepts, that would be approximately 20 words. Learning objectives, approximately 70 words. Then you have your first activity, which relate to those 3 dot points I just read out. Activity 1 would be around 600 words, and within that activity you would include your resources. That's how I would do it. You would include your resources for it, which would probably be about 10 to 20 words. And the same goes for the next activity. In the activities, I would weave these through where appropriate, but you could have a separate heading for this too, up to you. An assessment strategy for each of the activities. So that is included in the 600 word count. Headings are not included. The Australian curriculum content descriptors not included in your word count. So don't worry about that. We want good lessons. And we know it's a fairly tight word count, and that's why they're not included at all. Neither is your reference list. So I had a go at this. This is more than the second go I've had, because I actually did misunderstand it at first. I thought they were 2 separate activities, 2 separate year levels, 2 separate content descriptors. No, it's 1 content descriptor and 2 activities that link to that, both for the same year level. So I've just had a go at writing 1. The first one I did were rotational activities. I liked my activities a lot, and I'm actually going to implement them in my prep grade, but I found it hard to link that to PBL effectively. It's sort of, I kind of touched on it, but it wasn't, would definitely not have got an HD, that's for sure. So I've done another one. This probably wouldn't get an HD either, but we'll see. I haven't marked it. But I wrote an overview. The examples we've seen from the on-campus implementation of this unit, the students who got a distinction or higher distinction did have an overview. And this is how you can get your academic references in there. Because remember, in real life, in a school, we don't include academic references to support our decisions. But we do a lot of research to develop our activities. This is a university setting, so you do have to include academic research because we're assessing your understanding of, good foundations of your lessons and why you've done them the way you have. So a brief overview. This might be a little bit long, but I did count the words and it was kind of just in there, so it worked okay. So I included an overview for this activity, and you can read this in more detail on the slides. I'm not going to read it out to you, but I'll briefly go through it. So I've linked the activity to the students' classroom interest in Beyblades. It reflects a problem-based learning approach, which is known to facilitate deeper learning through authentic resolution of problems. So their little problem applies to something they're interested in and is relevant to the students. Other benefits of PBL include development of greater motivation, interest in subjects, learning satisfaction, confidence in learning, etc. And I've used an academic reference to support that. So I'm posing the problem to my grade. The toy factory's closed down and there's a shortage of Beyblades. You've been asked to design and produce an innovative spinning toy. The design that spins for the longest will be produced for sale. So this is designed to have multiple results. There's not just one straight answer. The children get to explore, they get to discuss with each other, they get to work in little groups, and they get to analyse their results and make changes. So this is how it fits into the PBL for me. So this opens a variety of complex issues since not all spinners look the same. So I've kind of popped a little bit of the science justification in there and talking about forces. I've also put in an Australian curriculum reference as well to support my discussion and a little bit about the benefits of collaborative learning. I've also included a bit about ICT here and how I've used it to engage, research and record. So students in this activity will be using an app throughout, Explain Everything. And they'll be recording the process. I am assuming that because this fits into a unit of work, or these children have got previous experience of using Explain Everything. And I do see the typo there. So you can make assumptions that they do know how to do something. So this lesson is not teaching them how to use Explain Everything. Explain Everything is used to record information and engage the students in ICT. ICT is also used in other ways in this lesson. So, my year level and content area, Year 2, Physical Science. So these are the headings you have to use. Key concepts. My first dot point is straight from the Australian curriculum, Science Understanding. A push or a pull affects how an object moves or changes shape. And I've put the CD link in there. I would expect that you probably reference that correctly too, which I haven't. I've also put a few more in about different strengths of pushes and pulls affect the movement of objects. A force is not something that an object contains or has in it, and a force is exerted on one object by another. And these are the key concepts that my 2 lessons are going to be looking at developing. And then I've got my learning objectives. Now, learning objectives, I always think in doing them smart, that they're measurable, they're achievable within that time frame, and they link to the key concepts. Maybe once you've written the 2 lessons, you might need to adapt these a little bit, so they're a little bit more broad, but mine are specific to this lesson. Students will explain that people can move an object by pushing and pulling. Students will change the speed and direction of an object by changing its weight, shape, and by pushing and pulling. Students will work collaboratively to construct toys, compare findings, and devise different solutions to make improvements. Students will use ICT to investigate, record, and explain their understandings. In my mind, I think learning objectives should be accessible. These are things that you should be able to go, can the students do this or not by the end of the lesson? Do they need more support? Do we need more lessons on these learning objectives related to the concept? Then I have my list of resources for this lesson. You can look at that on the slides on the Padlet. So this is my activity linked to those key concepts and the objectives. I've got a whole group introduction where I pose the problem, which I read out to you before about the shortage of Beyblades and their challenge. And then I let them know that we're actually going to focus on force for this activity. The first thing we're going to do is a quick think, pair, share. So that's one of the strategies I'm using in my lesson. Effective pedagogy, good strategies that we know that work in our classroom. And the think, pair, share is name as many objects or toys that you can pull towards you or push away from you. So they think by themselves for a couple of minutes, then they pair up with somebody in the classroom, have a chat, and then they share their ideas. And sharing ideas is my pre-assessment. I'm going to create a T-chart with headings push, pull, and the students will individually write 2 to 3 examples of a push or a pull on a sticky note and tape it to the appropriate column. They can draw if they're little. As a whole group, then we're going to evaluate where we put our choices and change them if need be, and have a little discussion on that, and we'll bring up some of the science ideas and we'll highlight keywords like push, pull, heavy, light, smooth, rough, gravity, friction, etc. Then as a whole group, we're going to watch a video on pushes and pulls. That's another way of incorporating ICT to engage them. We would like to see more than just watching videos in your activities. So following the video with a group discussion about how push and pull are both forces, I've put a little bit of the science in their explanation, just for my own benefit when I'm teaching. Then as a whole group, we're going to watch another video, but this is more specific about spinners, to get them engaged in the activity they're about to do. So the body of the activity, I'm going to divide the children into groups of 3. Each member will be provided with a rotating role, which I've chosen it to rotate so everyone gets a little go. And usually PBL, you do have roles in a group and you don't have great big groups. Great big groups don't work effectively in a classroom. I've taught for 20 years and I know a group of 3 or pairs are really good. Sometimes they do have to be a little bit bigger, but depending what you're doing. My roles are recorder, interviewer and manager. So the teacher will roam around asking prompting questions while the groups work collaboratively, interacting and creating various objects that demonstrate pushing or pulling. I've split my lesson into 2 like a table. I'm not sure why I did that. It just worked for me while I was doing that. If I was to hand this in as an assignment to my ELA, I might think differently, and I might just have it as those headings just straight underneath each other. So in this column here, each group, so they're broken into their groups. They've got 1 iPad per group, as you might have noticed in the list of resources. Each group are going to watch some brief video excerpts that I have bookmarked and put there. So they're not researching all by themselves. I've given them some ideas on different cultural examples of spinners and things. After viewing the videos, they'll have a group discussion. What kind of push-pull did they observe? Observe how when objects collide, they push on one another and change motion. Think about the different forces used to make the object spin, throw, spin, string, hands, whatever they used. Which shapes spun the longest? They'll watch them, and then in pairs, they're going to discuss those things I just mentioned and decide on the best type of spinner for their particular group to make based on their observations after viewing the videos. Then I'm going to think about diagnostic assessment in the next part of this activity, and I'll be collecting anecdotal records of students' ideas. For example, some students might have the misconception that all moving objects have an inbuilt ability to move. I'm going to encourage students but not put the answers into their mouths. I've got a little reference there to primary connections. So the next stage of my activity, I'm going to provide each group with a collection of toys to play with and explore, and these are all going to be very short little spurts in this activity, and they're exploring how they move or change shape when they move. So they're going to have a short time to play, they're going to select a few, and then the interviewer, using the iPad, is going to ask their group members, how did the toy move? Did the toy move the same way each time? What do you think made the toy move? Why do you think that? Did the toy change its shape? What kind of push or pull made the toy spin for the longest time? So they've got kind of a script, it's a bit loose, they might do something else. But we're trying to get some of their understandings in their decision making. So the recorder is going to use the video tool on Explain Everything to record the group members articulating their choices and reasoning. And this will be saved and added to the final presentation. In a lesson, I would time all this, but I haven't got it timed here because this is not a traditional lesson plan. So I'm going to allow a few minutes after this for the groups to look at a range of materials on offer to construct their spinners. So maybe 2 minutes, they can quickly go over, have a look at all of this, go back, discuss in their group which materials they need. Then, collaboratively in their groups, on paper, they're going to design a quick design of a spinner. They're going to include labels and a list of materials. Photograph that, so that image is going to be included in the final Explain Everything presentation. Next step, collect the items to construct the spinners. That will be the manager's role. They're going to go over, they're going to get all the things that they need to do this. And as a group, they go back, students collaborate to create their spinner based on their initial design. Then they test it. The recorder will film, the interviewer will ask, what works well? Could we make it spin faster or longer? How will we do that? They can present that any way they like. Then they get a little bit more time to modify their spinner and change it based on their discussions. Then they get to test it again, and a new recorder will film it, and the group members will explain how their final spinner works. And finally, the summative assessment. The teacher will use the Explain Everything recordings and use an assessment rubric, which like just a tick chart with the objectives on there, to record, and probably some other things, to record understanding of expected objectives. So see attachment. I haven't put an attachment here, but I would make a checklist. So the last step for the kids, well, not quite the last step in the body of the activity, complete their Explain Everything, so they've got time to link it all together, turn it into a usable presentation. They need to add an introduction to explain the challenge and add any labels or annotations needed and upload this to a shared drive for later viewing. There are other ways of uploading it and sharing it too. And just a conclusion, pack up. Gather for spinner competition, because that was the whole point of the activity, and as a whole group, think about which spinners worked most effectively and spun for the longest. Then we would discuss our findings and observations of different forces, discuss how the concepts of motion, push, pull and friction can be applied to real-life situations, and Explain Everything presentations to be viewed on the interactive whiteboard as a follow-up. Now part 2. 5 to 600 words. You will analyse a range of assessment strategies for the activities you've created. You'll make comparisons through your analysis and then consider the benefits, the limitations, the implementation constraints of each. Because we all think, oh yes, I'll run around doing anecdotal records. I'll take photos. I'll do this. It's not all realistic. So when you do assessment, try to make it as easy and realistic as possible and give you the most information. Really, I've said I'm going to use that Explain Everything for my assessment. How I would do that is I'm sitting there with my checklist as I'm viewing them, ticking it off, because I don't want to scroll through a whole lot of videos at the end to work out, did the kids understand that? And it would be quite hard. So think, is it realistic and will it show me the information I'm looking for? You'll use academic literature to consider and compare the assessment strategies. And in both of your lessons, why did you choose them? Why were they relevant for that particular lesson? And what were the benefits? Were there any limitations? And if so, what and why? You also need to think about, why do teachers need to assess? What is the purpose? And week 5 looks at assessment strategies for teaching and learning in detail, and also week 6. So please keep up with your readings. This will be invaluable for you. Also, problem-based learning or project-based learning is thoroughly covered in week 4, and there's a lot of great information out there that you can find. Also, information and communication technologies is covered in week 4. Did I say PBL week 4? PBL week 3, ICT week 4, assessment week 5 and week 6. And I think that's it. And the only other thing I wanted to do, now you're going to see my messy desktop, Australian curriculum. So you'll go to the Australian curriculum or yours. I'm just using the Australian curriculum, science. Select the year level you're interested in. So let's say year 2, that's what I did. Submit. You can look at all of them and then make your selection from there. It's the coronavirus meltdown of the internet. I'm not sure why this is not opening. Oh, did it open? Oh yes, and then scroll down to your content descriptors. And I'll bring this in a little bit smaller for you. I'm sorry, I'm really keeping you a little longer than I planned. Oh no, I don't know whether that did work. Oh, content descriptors, there we go. So you've got biological sciences, chemical sciences, earth and space, physical. I chose physical. I clicked on the elaborations over at the side and I was looking at the push and pull. And you can look at the elaborations which give you an idea of the kinds of activities that would be relevant for that particular content descriptor. These are adaptable. These are just ideas or suggestions that would be relevant. And a quick look at the assessment criteria, which you do need to keep into consideration. And after you've thought of your activities, have a good look through and decide whether you've met them or not, and can you make some changes to make sure you do, because it would be great if you all got high distinctions. We don't want a bell curve. We want everyone getting great marks. So, knowledge and understanding of how your selected content and concepts are addressed. So to pass, a developing understanding has been demonstrated as to how content and concepts are addressed. A problem-based learning approach has been included. That is to pass for that first criteria. You must include a problem-based learning approach in at least one of your activities. It doesn't have to be in both. You might want to do a 5Es approach in the other one. The resources you've selected are mostly relevant to the designated content description and year level. The next criteria to pass, you need to have evidence that you've used ICT to engage children in science. So it's been used as a vehicle for science. But for more than a pass, you need to integrate it more effectively and in a more engaging manner. And the fourth one, analysis of assessment strategy to pass. You need to show a developing knowledge of concepts of assessment and that they've been shown. So with an attempt to make some comparisons. So you must attend to all of these at the most basic level, and we're looking for better than that. So have a read through these. And as always, presentation, academic expression and referencing, which is only worth 10%. And but sometimes if you really haven't carefully proofread and there's lots of spelling errors and things don't quite make sense, it really takes away from the other parts of the academic, from the criteria. So it takes away from the content that you're showing your understanding. So whilst it's only worth 10%, please make sure you have a good proofread. What I notice when I read mine out aloud to you, I see mistakes. Have a read out aloud of yours, and if it doesn't make sense, it probably won't make sense to us when we're reading it, so we'll need to edit it. And it's a really good practice to do that. And you do need to reference APA style as always. So I hope this has been helpful, and I'll sign off now, and we're going to have our live collaborate, and hopefully you'll get to ask lots of questions there. Thank you for your time, and I hope everybody's well and taking care of each other at these strange times. Yeah. See ya.